In this video, we will be studying about mathematics. Students, in this video, we are going to solve practice set number 14. I'm going to begin with question number 2. Now, we will be doing question number 2. In question number 2, we have to find HCF and LCM of the given numbers. Let us look at the first pair of numbers. First pair of numbers is 14 and 28. So you're going to write 14 and 28. And we are going to factorize them. So let us start factorizing them. 2's are 7, this goes 14's are. Then you have a 7, 1 and 2. So what is the HCF over here? HCF is equals to 2 multiplied by 7, that is equals to 14. And LCM is 2 multiplied by 7 multiplied by 2, that is equals to 28. So HCF of 14 and 28 is 14 and LCM of 14 and 28 is 28. We'll do one more sum. The sum number 3. In sum number 3, the sub question number 3, you got three numbers 17, 102 and 170. So 17, 102 and 170. Now 17 is a prime number, so it won't go in any other table other than 1 and itself. Okay, so you're going to write 17 over here, and in all these numbers go in the table of 17. 17 1s are 17, 17 6 are 102 and 17 10s are is 170. So other than this we cannot factorize any more further. Therefore HCF is 17 and LCM is 17 multiplied by 6 multiplied by 10, that is equals to 1020. Students, question number 3 is to find the LCM. I hope you will be able to find the LCM of the given pair of numbers or the numbers given there by yourself. Okay, now let us move on to question number 4. Now question number 4 is an application type of question, which means you are going to apply the knowledge of your HCF and LCM in these type of questions. Let us read what the question says. The question says, find the smallest number which when divided by 8, 9, 10, 15 and 20 gives a remainder of 5 every time. Again I am reading the question. It says, find the smallest number which when divided by 8, 9, 10, 15 and 20. 8, 9, 10, 15 and 20 gives a remainder of 5 every time. Every time. Now what we are supposed to do? We have to find the smallest number when divided by this gives a remainder of 5 every time. Okay, which means we have to find a number. When we divide that number by any of these numbers, the remainder which you get should be 5 every time. Okay. Now, smallest number. What topic are we doing? We are doing HCF and LCM. Smallest means the least. So what we are going to do over here is we are going to find out the LCM. We need to find out a number, the smallest number, which can be divided by all these numbers to give you a remainder as 0. Okay, very first thing, the first thing we are supposed to find out is that we have to find a number which is the smallest number, which when divided by all of these will give you the remainder 0. That means we are supposed to find the LCM of all these numbers. Okay, so let us find out the LCM of all these numbers together. Okay, so you got 8, you got 9, you got 10, you have 15, and you have got 20. Now students, over here what I'm going to do is I'm going to have a bit of different approach. Why? Because see, you cannot find a single number wherein it will divide all these given numbers. Okay, so you can have 2 which divides 8, 10 and 20, but 2 does not divide 9 and 15. You can have 3 divides 9 and 15 but does not divide 10 and 20 and 8. So what we are going to do is we will keep on factorizing each number by the smallest factor which we get until we can divide it. For example, how to move around. See, there are even numbers 8, 10 and 20. So this can be factorized by 2. Okay, so what I'm going to do is I'm going to factorize by 2 until I get numbers which cannot be factorized by or divided by 2. So this goes 4. 9 cannot be factorized by 2, so I'm going to keep 9 as it is. 2 and 10, so this becomes 5. 15 does not comes in the table of 2, so I'm going to write 15 as it is. And 20 divided by 2 is 10. Okay, then again I've got 4 and 10 again goes in the table of 2. 2 2s are 4. 9, whichever number you cannot divide by 2, you have to write that number or repeat that number without making any changes. Okay, so 9. 5 cannot be divided by 2, so I'm writing 5. 15 cannot be divided by 2, so I'm writing 15, and 10 I have got 5. Okay, now again 2 is there, so 1, 9, 5, 15, 5. Okay, now look at these numbers. These numbers are not divisible by 2. These numbers are not divisible by 2. So we'll go to the next number, 3. 9 is divisible by 3 and 15 is also divisible by 3. So 3. 1, because there is nothing more. This factorization has ended. So I'm just going to repeat 1 over here. So 3 3s are cannot divide 5 by 3. So I'm going to write 5 here. 15 divided by 3 is 5 and 5 again. Again 3, 1, 1, 5, 5, 5, and lastly I've got 5, 1, 1, 1, 1 and 1. Now what is the LCM now? The LCM is the multiplication of all of these. So what is the LCM? LCM is equals to 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 5. So 2 into 2 into 2 into 3 into 3 into 5. Okay, so let us multiply. 8 5s are 40. 40 into 9 is 36. So 360. So LCM of all these numbers is 360. Okay, which means if I divide 360 by any of these numbers, my remainder will be 0. My remainder will be 0. But what should be my remainder? 5. What should be my remainder? 5. So what I'm going to do is I'm going to add 5 to this number. Let us see what happens. See, if I divide 360 by say 2, sorry 8, 8 is 360 divided by 8. So what is the remainder I'm getting? 8 4 is 32, 4 0, 5 is 40. I'm getting the remainder as 0. But what I need the remainder as 5. What I'll do is I'll just take 365. What happens if I take 365 and I divide by 8? Again, 8 4 is 32. Then what is this thing you're getting? 4 5. 8 5 is 40. So what is the remainder you are having? 5. The same thing applies for 9. The same thing applies for 10, 15 and 20. So if you divide 365 by any of these numbers, your answer or your remainder will be 5. Okay. So the required number, the required smallest number, which when divided by 8, 9, 10, 15 and 20, giving us a remainder 5 is, so required number is the LCM plus 5, that is 360 plus 5, that is 365. I hope you have understood this sum. Now let us look at question number 5. Question number 5 says, reduce the given fractions to their lowest terms. So they have given some fractions to us. We are supposed to reduce them to the lowest terms. I'm solving the first sum for you. The first sum is 348 divided by 319. So we are supposed to reduce them. Now in order to reduce them, what we are going to do is we are going to first find out the highest common factor. We need to find out common factors. So if we get the highest common factors which can divide both these numbers, our work will be done in a much more easier manner. So what we are going to do is we are going to find the HCF of 348 and 319. So we are going to do this, we can do this either by the regular method or also by division method. So we are going to approach this with the division method. So 348 divided by 319. 319, so 1's are 319. You get remainder as 29. Okay, when you subtract them, the answer is 29. So what you are going to do the next thing? The next thing is you're going to divide 319 by 29. So 29 1's are 29, 29 1's are 29. So the remainder is 0. So the remainder is 0. Therefore, HCF is equals to 29. So HCF is equals to 29. So what you're going to do is you're going to divide both 348 and 319 by 29. So therefore 348 upon 319 equals to 348 divided by 29 upon 319 divided by 29. The answer is 12 upon 11. 348 divided by 29 is 12 and 319 divided by 29 is 11. So the reduced fraction is 12 upon 11. Now let us look into question number 6. The question number 6 reads, the LCM and HCF of two numbers are 432 and 72 respectively. If one of the numbers is 216, what is the other number? So what they have said is the LCM and HCF of two numbers are given. So LCM is equals to 432 and HCF is equals to 72. They have said one number is what? 216. You have to find the other number. Okay, so how you are going to solve it? Now solution, we'll say let the other number be x. Let the other number be x. Okay, now we know product of two numbers is equals to the product of their HCF and LCM. We have solved such type of sums in your practice set number 13. The product of the two numbers is equals to HCF into LCM. Now what are the two numbers? One number is 216 multiplied by what is the other number? The other number is x. So product of the first number and the second number is equals to product of the HCF and the LCM. That is 72 multiplied by 432. Okay, now what you're going to do is, this is a multiplication. When you take on that side, it becomes division. So x will be equal to 72 multiplied by 432 upon 216. So we can directly cancel it. 216 ones are, and this goes to 0. Okay, then so x is equals to 72 multiplied by 432. Therefore 72 multiplied by 2. Therefore x is equals to 144. So x is equals to 144. So the other number is 144. I hope you will be able to solve question number 7 by yourself, because it is same as question number 6. Now let us move on to question number 8. Let us move on to question number 8. In question number 8, we have a trader has 3 bundles of strings of length 392 meters, 308 meters and 490 meters long. What is the greatest length of string that the bundles can be cut up into without any leftover strings? I'm reading the question again. It says a trader has 3 bundles of string 392 meters, 308 meters and 490 meters long. So the measures of length of strings in each bundle is given to you. Now we have to find the greatest length of the string that the bundles can be cut up into without any leftover strings. So for example, if we take the first string bundle of string, it is 392 meters. Now we have to divide that 392 meters in equal parts. Okay, similarly you have to divide the bundle of other strings also in equal parts, but they are asking us what will be the length, the greatest length, such that there will be no strings left after that. Means you have to find the length of that string to be divided such that when you cut them into that length, there will be no extra strings left. So in order to do this, see, you're going to divide them. So dividing means you need to find out the factor. Okay, so in order to solve this, we need to find out the highest common factor. So with what are the lengths of the strings? 392, then 308 and 490. So these are the lengths of the string. So what we are going to do is we are going to find the highest common factor of these numbers so that we'll get our answer. So let us start dividing by 2. 2s are, 2 1s are, then 9s are, 6 are. Then again 1, 5 and 4. 2, 4 and 5. Okay, let us see if these numbers are divisible by say 3. Can we divide these numbers by 3? No. Can we divide these numbers by 7? Yes, these numbers can be divided by 7. So 7, you will have 7, 2s are 14 and 5, 8s are 56. Then this goes 2s are 22s are. Then this goes 3s are 5s are. So after this, you cannot have a single number which can divide all these 3 numbers. So your HCF is 2 into 7, that is equals to 14. So the trader has to divide the strings into pieces of 14 meter each, and that string, that length will be the greatest length of those parts wherein you won't have any remainder strings. Okay students, let us solve sum number 9. Here we have to find two consecutive even numbers who have LCM of 180. Okay, so here we have to find two numbers whose LCM is 180. Okay, now what are the properties of the two numbers given? They said they are supposed to be consecutive even numbers. Consecutive even numbers means what? Numbers which come one after the other. Like consecutive numbers are which just come one after the other, like 1 2 3 4 5 6. These are called as consecutive numbers. So what will be consecutive even numbers? Consecutive even numbers will be 2 4 6 8 10 and so on. These are called as consecutive even numbers. So we have to find a pair of consecutive even numbers whose LCM is 180. So let us solve the sum. Now since 180 is the LCM of those numbers, which means 180 when divided by those numbers, the remainder will be 0. That is, they will be the factors of 180. So what we are going to do is, first things, we are going to list down all the factors of 180. So what are the factors of 180? Factors of 180 are 1, 2, 3, 4, 5, 6. Then you got 9. You have got 10, 12, 15, 18, 20, 30, 36, 45, 60, 90 and 108. Okay, so these are the factors of 180. Now we need consecutive even numbers. Okay, so we need even numbers. So what we are going to do is we are going to take down all the odd numbers. Chalo, take down all the odd numbers from here. So we will take down all the odd numbers. So these are the odd numbers which we are taking in. 15. Okay. So once we have taken down all the odd numbers, we have got the even numbers. Now we are going to look at the consecutive even numbers. So which are the consecutive even numbers? So 2 and 4 are consecutive even numbers. Okay. Then again 4 and 6 are consecutive even numbers. What else? 10 and 12 are consecutive even numbers. Then 18 and 20. Okay. Now, other than these, I don't think there are any other consecutive even numbers which are factors of 180. So, the pair of consecutive even numbers which are factors of 180 are 2 comma 4. Then you got 4 comma 6. Then you have, I would not draw these lines, 4 comma 6. Then you got 10 comma 12 and you got 18 comma 20. Now we have to only do one thing now. The only thing we have to do is we have to find the LCM of these pairs. Once we find the LCM of these pairs, it will be clear that which pair has the LCM of 180. So let us look at LCM of 2 comma 4. What is the LCM of 2 comma 4? The least common multiple of 2 and 4. If you solve it, you will get as 4. The least common multiple of 2 and 4 is 4. Then the LCM of 4 and 6. If you solve these, then the LCM of 4 and 6 you will find is 12. The LCM of 4 and 6 is 12. Then LCM of 10 and 12. LCM of 10 and 12. What is the LCM of 10 and 12? 10 and 12, the LCM is 60. And LCM of 18 and 20, you find out it will be 180. So what was the question? We have to find a pair of even consecutive numbers whose LCM is 180. So we found out the pairs of numbers which are the even consecutive even numbers which are factors of 180. Then we took out their LCM to check which pair has the LCM of 180. So the pair of 18 and 20, the LCM of the pair 18 and 20 is 180. So the required numbers, the required two consecutive even numbers whose pair is 180, whose LCM is 180 is 18 and 20.